Okay, in this meeting, we are going to cover one of the topics in chapter 3.6. There is actually a second topic in here, which is the derivatives of the inverse trig functions. Yeah, you should know they exist. You should know what they are, but I'm not going to hold you responsible for them. They're not used that often. But again, you should know that they exist. So in this section, we're going to cover the derivatives of logs, two types of logs, the natural log and the base B log. So these derivatives are in the textbook. They're also on that formula sheet because these are going to involve the chain rule, the inner chain rule. So if we have, and I'll write these derivatives down here, if we have a function in the form of the ln of u, then y prime is equal to u prime over u. Now, again, this is an inner chain rule. So remember that all of our derivatives from now on must involve that chain rule. The other log is the base B log. So anything in the form of y equals the log of b of u, the derivative y prime is equal to u prime over u times the natural log of b. Okay, let me show you these. And then I'm going to run through a couple, quick examples of each one of these. And that will cover this section. All right, so these are your two log derivatives. They're on that formula sheet that I sent to class. And they involve the inside chain rule, where the natural log of u, where u is a function other than just x, although the formula will work even if u is just equal to x. So let's take a look at an example of each one of these. All right, so suppose we have the function y equals, we'll do the natural log first. Y equals the natural log of 2x to the fourth. So notice in this that u, which is the inner function, u, is 2x to the fourth, which means that u prime is equal to 8x cubed. So that means in following the formula that y prime is equal to u prime over u, which is 8x cubed over 2x to the fourth. This must be reduced, of course, and we end up with 4 over x. All right, let me show you this. Again, notice that I am taking the time to show you what the chain rule is in terms of u. U is equal to the 2x to the fourth. And of course, we need u prime in the formula. So it's just plug and chug and reduce. Now let's take a look at the second one. And again, I'm only doing a couple quick examples of these. There's going to be a lot of different ones in the book that you should be doing. And there's going to be a lot of them in the WebAssign that you're going to be doing as well. Make sure to always give your answers in simplest form because WebAssign probably won't accept them. So let's take a look at the other type of log. So let's say that y is equal to log to the base 3. Okay, log to the base 3 of 4x cubed. I will identify what my u is. Again, I'm doing this formally, which you should do. You don't have to, but you should develop this habit. Eventually, we're going to be doing integration in here at the end of the course. So you might as well get used to this now. So my u is equal to 4x cubed. And my u prime is equal to 12x squared. Now, notice once you've done this, it makes life easy on you, because to use the derivative formula, all you're doing is plugging in and reducing where you can. All right, so notice this one, I've identified u and I've identified u prime. And so therefore, to find y prime, all I have to do is know the derivative formula and plug in for u. And b, of course, because b is the base. This is log base 3, by the way. That's what it means for any of you that might remember about logs. All right, so I have y prime is equal to u prime, which is 12x squared, divided by 4x cubed times the natural log of the base, which is 3. Of course, I'm going to reduce this now. In WebAssign, when you give answers, you don't have to show your work. You'll be showing the simplified answer. But on your exams, yes, you do. Absolutely. Exams and labs, you must show your work. If you skip work, you lose points. So I'm going to reduce this to 3 divided by x times the natural log of 3. All right, let me show this to you. Okay, so notice by identifying u and u prime, then using the derivative formulas are just plug and chug and reduce. You always give your answer in simplest form. Okay. Let's try one more. Let me erase this stuff. I'll keep the formulas on here and we'll do one more. Let's do one involving a trig function. And as I mentioned before, if any of you, or actually some of you are not reading emails, it's clear, because I have requested responses and very few people are paying attention to emails. Reason you need to pay attention to emails is because I am making announcements, obviously through emails, things you need to know and need to be able to do if I request it. Also, I'm sending documents to you. I don't care if you read your emails on your phones, but you're not doing any work on your phone. You shouldn't be doing your WebAssign, and you should be trying to do your labs or your exams. So let's try one more. Suppose we have the function y equals the natural log of the sine of x. And technically, I'm going to rewrite this as the natural log of the absolute value of the sine of x. Now, why absolute value? Because you're not allowed to take the natural log of a negative number. You're also not allowed to take the natural log of 0 either. So this would definitely have some restrictions as to what values you could use. Let's take a look at this then. We'll identify what u is. Obviously, u is the inner function. This is an inner chain rule. So my u is sin x, which means my du, or my u prime. So my u is sin x. And that means that my u prime is cosine x. So therefore, y prime is u prime over u, which is cosine x divided by sine x. But technically, we don't want to leave this answer like this, again, just because textbooks and what was signed probably wouldn't leave it like that either. So knowing your trig identities, I'm going to rewrite this as the cotangent of x. So my y prime in simplest form, not that it's wrong to leave it like this, but just being aware that software usually gives you your answer in simplest form, although you're not using software. But when you go to check the answers in the back of the book, that's what they're going to be leaning on. So the answer is cotangent of x. That's the answer in its simplest form. Okay. And there you go. So this covers the topics in chapter 3.6 on derivatives of the two different types of log functions that you're responsible for. Natural log, which is the base E log, and the base B log, which can be any other number. Depending on which one you're dealing with will depend on which derivative formula you're going to be using. Remember, watching these videos are mandatory. I'm not really tracking it, by the way, but watching these are in fact mandatory. Okay, I mean, I could track it, but I haven't been. All right, so let's stop this recording.